to find the electrical field intensity due to the complete conducting sphere. So for the application of a conducting sphere, we mainly use the wire, the copper wire. So this copper wire has one is the positive cable, okay, positive charge. The other one is the negative one. So if this type of the sphere is available, then how to find the electrical field intensity? So like this, if I take an example, this is in a sphere and charges are either inside the sphere or outside the sphere. So in this case, we are considering the charges over the spherical surface like this. Those charges, they are placed like this pattern on the sphere. Okay, when the charges are placed over the sphere, so there will be three cases. As you know that if I take a center of this sphere and draw a line from center to this point, this will be our radius. This will be our radius r. So there might be three cases. Maybe the point of interest is outside the sphere, maybe over the sphere line, the gaseous line, or maybe inside the sphere. So these three conditions may exist when we are considering the spherical surface. Okay, one is outside when r is greater than the radius r. Suppose this is the radius r. If this is the radius r, the radius of the point of interest where we need to find the electrical field. So we need to find the electrical field at this point of interest having coordinates maybe r, theta and phi. Maybe this point of interest is over the line, that means the r is equals to the capital R, or maybe the point of interest is inside the sphere, then r is less than the capital R. Is that clear? If such type of the case is coming into the paper to find out the electrical field intensity due to the conducting sphere, then you have to discuss these three cases. So this one is the radius r. So first we are going to discuss case number one, where the r is the radius of a point of interest. Radius of a point of interest. If r is greater than the radius of the sphere, this is the radius of the sphere. If this is the point of interest where we need to find the electrical field intensity, then this one will be the radius r. So to cover this point of interest, what we do, which type of the Gaussian, which type of the loop is used? As I already tell you, okay, we are discussing the Gauss's law. So the loop that is covered by this point of interest will be the Gaussian loop. So we need to draw a Gaussian loop over this point of interest. Okay, first we need to place the charges like this. So to use the Gauss's law, we need to determine the electrical field intensity. This is the formula for the Gauss's law. If you recall your memory from the Gauss's law, the closed path surface integral of E dot ds is equals to the total charge enclosed divided by the epsilon naught, So first I need to draw the Gaussian surface. So the Gaussian surface will look like this. Okay, Gaussian surfaces look like this. So these charges are inside this Gaussian surface. ये जो charges हैं, ये आपके इस Gaussian surface के inside हैं. So the formula will be Q inside divided by epsilon naught. So as you need see that at every point, suppose if I take a point here, or if I take a point here or here, at every point the radius is constant. When the radius is constant, the electrical field is constant. So this will be your second condition that to find out the electrical field intensity, the electrical field must be constant. The electrical field must be constant. So see that at every point, the electrical field that is basically created, okay, that is the constant. So what we do, so our first step is to take a differential surface over this area. ये जो आपका area है, this is the shaded area. इस shaded area में हमें क्या करना होगा? So we need to take a differential surface. So like this, if I take a differential surface, this one is the ds, this one is the differential surface. So the electrical field line, so this one is the differential surface vector and this one is the electrical field vector. Both are parallel. The electrical field and the differential surface are parallel. So as you know that E dot ds is equals to E ds cos theta. So the angle is 0. When the angle is 0, cos 0 is 1. So E dot ds is equals to E ds. So if I solve the equation, the closed surface integral E vector dot ds vector, if I solve the dot product of these two vectors, the result will be E ds cos theta is equals to q enclosed divided by epsilon naught. So as I told you that electrical field at every point is constant, so this value is constant. So this will come after the integral sign. So theta, first we need to put the angle is 0. So cos 0 is 1. So the equation is the closed surface integral E dot ds is equals to q divided by epsilon naught, where E is constant. E क्या है? Constant है, ये integral sign के पहले आएगा. ds is equals to q over epsilon naught. So the closed surface integral of ds basically defines the area of the surface. Area of the surface. The area of surface क्या होगा? Spherical का क्या होगा? Anyone guess?
Sir, 4 pi r square.
4 pi r square. So the area, the closed surface area of a sphere is 4 pi r square. So we need to put here 4 pi r square. So we need to find the electrical field. So this value will be multiplied with this factor. So E is equals to Q divided by 4 pi epsilon naught r square. So this is the formula to find the electrical field intensity when R is greater than the capital R. Okay, if any problem, if the value of the radius of a point of interest is higher than the radius of a sphere, then you can use this formula.